Welcome back to Neural Intel. Today, we're doing a deep dive into some really interesting technical research.
Yeah, looking forward to it.
We're looking at how AI can get, well, personal, understanding and generating stuff that's specific to you, like your pet or a favorite mug.
Exactly. Moving beyond just knowing what a dog is to knowing your dog.
Right. We know these big models, these LMMs, large multimodal models, are already pretty amazing. They handle text, images, inputs, outputs.
Yeah, think of something like Chameleon. It can describe a Shiba Inu, no problem.
Yep.
It can probably even generate a decent picture of one.
Sure, the general stuff is covered, but the technical challenge, and this is what we're digging into, is that personalization.
Right.
Like asking it to describe your Shiba Inu, let's say his name is Bo, or generate a picture of Bo reading in a library.
Without ever having learned about Bo specifically. Yeah, that's where current systems often fall short. They just don't have that specific knowledge.
And that's the core technical problem, isn't it? How do you teach them these personal concepts?
It is. There's been progress, in language-only models, LLMs, and
Mhm.
also in just pure image generation. But combining it, getting an LMM to both understand and generate images and text about your specific thing, that's been a tougher nut to crack, technically.
Okay, so let's unpack the key technical hurdles here. Why is it so hard?
Well, one really big one is something called catastrophic forgetting. It's a classic machine learning problem, actually.
All right, I've heard of that. Explain it in this context.
So imagine you take a powerful LMM, one that knows a ton about the world, and you try to fine-tune it, like really drill down using just your few photos of Bo to make it great at generating images of him.
Okay.
The technical risk, is that in learning the fine details of Bo, the model might just overwrite or lose a lot of its general knowledge.
Ah, so it becomes amazing at Bo, but suddenly forgets what a cat is or how to answer general questions.
Exactly, or its general abilities get significantly weaker. That kind of defeats the purpose of having this powerful general assistant, doesn't it?
Yeah, definitely limits its usefulness. Okay, so full fine-tuning is risky. What about other approaches? The research mentions soft prompt learning.
Right, that's another technical strategy. It's a bit different. Instead of changing the whole model, you keep the main model frozen, its existing knowledge stays put,
Okay.
and you introduce just a small set of new, learnable parameters.
Hmm.
They often call them tokens or prompts. These are meant to capture the essence of the new thing, like Bo.
That sounds less destructive. Does it work?
It's better for avoiding catastrophic forgetting, for sure.
Ugh.
It works reasonably well for, say, teaching the model to recognize Bo in text descriptions. But the paper suggests it struggles when you only have a tiny number of images, like the 3 to 5 you might realistically provide.
Shribbles how?
Specifically with generating high-quality, detailed images of Bo. The signal from just a few images, learned only through those soft prompts, might not be strong enough for really good generation.
Okay, I see. So technically, we've got this trade-off. Fine-tuning risks forgetting. Soft prompts with few images aren't great for generation.
That's the dilemma.
Which sets the stage perfectly for the solution proposed in the paper we're looking at, Yo Chameleon.
Exactly. Yo Chameleon, building on the Chameleon LMM.
Yo, like Y-O-U-R, chameleon, I guess. Making it personal.
That seems to be the idea. Their technical goal was exactly this: personalize an LMM for both understanding and generation, using just those few user images effectively.
So how does Yo Chameleon technically get around those problems of limited data and forgetting?
What's the core technical ideas is pretty clever. They use something they call soft positive images.
Soft positive. Okay, what does that mean technically?
Well, normally you train with positive examples, pictures of Bo, and negative examples, pictures that aren't Bo.
Right.
Here, they take some of those negative images, specifically ones that look visually similar to Bo, and they treat them, well, not as negatives, but as soft positives.
Ah, so like pictures of other Shiba Inus that kind of look like Bo but aren't him.
Exactly. Or maybe dogs with similar coloring or shape. The idea is to use these visually related images to give the model more data points to learn from, even though they aren't the real target.
Mm.
It helps build a more robust understanding from your limited true positives.
That makes intuitive sense. You're giving it more related context. How do they manage that technically?
They do it quite smartly with an adaptive prompt length strategy.
Adaptive length.
Basically, the more visually similar a soft positive image is to your actual images of Bo, the longer the descriptive prompt associated with it during training.
So images that look really close get more attention, more descriptive power assigned to them.
Precisely. It allows the model to focus more technical resources, you could say, on the feature share between the true positives and the most similar soft positive.
That's neat. It's not just more data, but weighted data.
Exactly.
Yeah.
And they also combine this with hard negative mining. Those are the negative images that are particularly tricky, the ones that the model might easily confuse with them. Instead of just saying wrong, they also treat these hard negatives somewhat like soft positives. Their contribution to the learning is also scaled by how similar they look to Bo.
So even the confusing wrong examples help it learn the boundaries better.
Kind of. Think about training on Bo. A picture of a generic dog is less similar than maybe a yellow dog with pointy ears. Both are negative, but the second one provides more specific contrastive information. They even use adaptive token allocation for these.
More tokens for more similar negative.
Yeah, the more similar negative images get assigned more of those learnable tokens to capture relevant details, though the full set of tokens is always reserved for the actual positive images of Bo.
Wow, okay, that's quite a sophisticated way to squeeze information out of limited data by cleverly using the negative examples, too.
It is. It's about maximizing the signal from what you have.
Now, the other challenge was handling both language and image generation without them messing each other up. How does your Chameleon manage that technically?
Right. This is where they introduce the idea of dual soft prompts.
Dual prompts, meaning two separate sets.
Exactly. Two distinct sets of those learnable tokens. One set, which they call U tokens, is specifically trained and used for text understanding and generation tasks.
Okay, U for understanding, maybe.
Seems likely. And the other set, G tokens, is dedicated purely to image generation. G for generation.
Okay, separate tracks. Why not just use one set of prompts for everything? Seems simpler.
You'd think so, but technically their experiments showed it doesn't work as well.
Oh.
Yeah, it seems the features and nuances you need to capture for good language understanding are different from what you need for detailed image generation.
So tokens optimized for describing Bo in words aren't necessarily the best ones for drawing him.
Exactly. And if you try to train one set of tokens to do both jobs simultaneously, the performance on both tasks tends to suffer. It's a technical compromise that hurts both language and vision.
I see. So separating them allows each set to specialize properly. Makes sense. But then, how does the model know which set of tokens to use when I give it a query?
Another clever bit. They use a self-prompting mechanism.
Self-prompting.
Yeah. Before the model actually generates the response, it first makes an internal prediction. Is this query asking for text understanding, or is it asking for image generation?
So it classifies the task type first.
Basically, yes. Based on that internal prediction, it then automatically selects and prepends the correct set of tokens, either the U tokens or the G tokens, before generating the actual output.
That's quite elegant, technically. So if I ask, what breed is Skex, where Skex is my personalized concept identifier.
The model figures out, okay, that's understanding, and its internal process starts with U tokens, then it generates the answer. Like it's a personalized object type.
And if I ask, show me a picture of Skex sleeping.
It recognizes it as generation, starts internally with G tokens, and then proceeds to generate the image. It directs the query down the right specialized pathway.
Very cool. Okay, so that's the technical approach. How well did it actually work? Let's talk results.
Sure. They tested Chameleon using a data set they created called YoLava. It had 40 different subjects, different personalized concepts,
Then they compared it against
the original Chameleon model as a baseline, and also against Chameleon using some simpler forms of personalization, like just adding text prompts or image prompts describing the concept.
Right. And what did the numbers show? Did Chameleon pull ahead?
It did, quite clearly in some areas. For recognition accuracy, just correctly identifying the personalized object in text, Chameleon hit about 0.845 accuracy.
How does that compare?
That was a solid jump up from around 0.727 using just personalized text prompting with Chameleon. And interestingly, Chameleon achieved this using only 32 learnable tokens in total, 16 for U, 16 for G, which was actually fewer than some of the baseline setups needed.
Better accuracy with fewer resources, technically that's a win. How did it stack up against, say, a powerhouse like GPT-4o for language tasks?
They did compare its personalized language generation with GPT-4o. Recognition accuracy was actually pretty comparable, which is impressive given Chameleon used way fewer tokens. But GPT-4o was better at the general question-answering parts. The researchers basically said, look, GPT-4o is built on a more powerful base LLM, and the questions they used were fairly simple. So Chameleon holds its own on the personalization aspect in language, but doesn't beat GPT-4o overall.
Okay, understandable. What about image generation? You said that was the harder part for previous methods.
Yes, and this is where Yo Chameleon really shone technically.
Yeah.
Compared to the Chameleon baselines using just text or image prompts for personalization,
Yeah.
Yo Chameleon significantly outperformed them. They use CLIP image similarity to measure how well the generated image matched the target concept. Yo Chameleon scored 0.783.
And the baselines.
They were much lower, somewhere between 0.5 and 0.6. So a really substantial technical improvement in generating images that actually look like the personalized thing.
That's a big difference. How did it compare to GPT-4o on image generation?
This was interesting. GPT-4o, being very capable generally, could often capture the high-level idea, like a picture of your specific type of object.
What?
But it really struggled with the fine-grained, specific, personalized details, especially faces.
The uncanny valley problem?
Sort of. They measured facial similarity, and GPT-4o scored really low, like 0.028 to 0.036. The generated faces just didn't look much like the actual person.
In Yo Chameleon.
It did technically better at capturing those facial details. Not perfect, they admit, but definitely closer to the personalized target than GPT-4o managed in their tests.
So technically GPT-4 is great for general scenes, but Yo Chameleon has the edge for getting those specific personal details right, especially for things like faces.
That seems to be the takeaway from their results, yeah.
Did they do ablation studies? You know, taking bits out to see what really matters?
Oh yes, good ablation studies are key. They did several to really isolate the technical impact of their design choices.
Always insightful.
Right.
What were some of the key technical findings there?
Well, first, they confirmed that those soft, positive images were absolutely crucial for the good image generation results.
More important than just using the original few positives?
Significantly better, technically. Better than just using the positives, and also better than trying standard data augmentation tricks, like, say, in-painting on the positive images. That soft positive strategy really carried weight.
Okay, so that technique is definitely pulling its weight. What else?
They looked at the number of soft positives. Generally, adding more tended to boost performance, up to a point, of course.
Makes sense. More related data helps.
They also tested the number of learnable tokens, those U and G tokens. They found that performance improved as you added more tokens, but around 16 for each task seemed like a good sweet spot, balancing quality and efficiency.
16 for understanding, 16 for generation.
And, as we discussed, their ablations technically confirmed that using separate U and G prompts was better than trying to share one set. Sharing just degraded performance.
Right, reinforcing the dual prompt idea?
Exactly. And finally, they did explicitly compare their soft prompt tuning approach against full model fine-tuning on the personalization task.
And confirmed the catastrophic forgetting issue.
Yep. Full fine-tuning led to a significant drop in the model's general abilities, whereas their Yo Chameleon method preserved that general knowledge much better.
Okay, those studies really nailed down why their specific technical choices matter. Did they mention any limitations? Where does it still struggle?
They were upfront about limitations, yeah. One area is objects with really fine, intricate details.
Like what?
Like trying to get legible text on a specific coffee mug in the image, or rendering all the tiny keys on a particular keyboard accurately. It still has trouble with that level of fine detail.
Okay, high-frequency details are hard.
Right. Also, it inherits limitations from the base Chameleon model. For instance, generating images with multiple distinct concepts accurately interacting can still be challenging.
So putting Bo and your specific cat and a detailed background object all together perfectly might still be a stretch.
It might, yeah. And finally, while it improved on facial similarity compared to GPT-4o, they acknowledge there's still a gap in accurately personalizing human faces to a really high fidelity. Their scores were better, but maybe still below what you'd consider truly photorealistic recognition level.
So still technical room for improvement, especially on fine details, complex scenes, and faces. Got it.
Definitely.
Okay, so let's try and summarize the core technical takeaway from this deep dive.
I think the main point is that Yo Chameleon presents a really solid technical approach for personalizing these powerful LMMs for both language and vision, using just a handful of examples.
And the keys were those clever techniques like soft positives and the dual prompts.
Exactly. Those seem to be the critical technical innovations that allow it to learn effectively from sparse data while avoiding catastrophic forgetting and handling both modalities well.
And what are the bigger technical implications here? Where might this lead?
Well, technically, this opens the door to AI assistants that are much more useful in your personal context, right? Imagine an AI that doesn't just know about a car, but but knows your car or your workspace or important people in your life and can reason about them and even generate content related to them.
Much more integrated and genuinely helpful AI.
Potentially, yeah. And doing it without crippling the AI's general knowledge is key for making it practical.
Really fascinating technical progress. It certainly makes you think about how we'll interact with AI down the line, having it understand our personal world so much better. What do you think is the next big technical hurdle to overcome those limitations, the fine details, the multi-concept stuff?
That's a million-dollar question, isn't it? Maybe advancements in attention mechanisms, or perhaps entirely new ways of representing and composing concepts within these models. It's definitely an active area of research.
A technical challenge to keep an eye on. Well, for anyone listening who wants to dig into the really nitty-gritty technical details, the research paper itself is linked over on our Neural Intel webpage. Definitely check it out. Thanks for joining us for this technical deep dive.
My pleasure. Always fun to get into the weeds.